There are certain situations in statistics where we are looking at confidence intervals, but a margin of error is already predetermined that we were supposed to abide by. And we also have the confidence level that we want to meet. So in those sorts of situations, what we need to do is figure the sample size, how many we need to have in our sample, so that we are able to have that particular margin of error and meet our level of confidence when we're doing our confidence interval. So these questions are, how many do you need in your sample? How many need to be sampled? Find the number of items in your sample such that you are key indicators that it's a sample size question. Now we might be asked to find sample sizes for the population parameters of proportion with an estimate for p-hat, proportion without an estimate for p-hat, the mean, or also the variance or standard deviation. For each of these situations, you need to predetermine which one it is that you have, so you know which formula to use or if there's a table that you need to reference. This video will be going through an example where we're asked to find the sample size with looking at a population mean confidence interval. Here it says, find the minimum number to be included in the sample, so find the number in the sample to be 92% confident that the population mean is within 12.58 of the sample mean. A pre-sample of size 64 gave a sample standard deviation of 97.49. So we want to know what the minimum number we have to have in our sample. They give us a level of confidence, and this within the 12.58, that is the number E. That's that margin of error that they're predetermining that we want to have. So whenever you see the word within or plus or minus this amount or that sort of thing, that's your key indicator that the number following that is your E. Now, I've written up 3 of the different formulas for finding sample size. The first one here is n is equal to p-hat times 1 minus p-hat times the quantity z sub alpha over e, or z sub alpha over 2 divided by e quantity squared. This is the formula for sample size if you have the question asking you for the sample size and it's a confidence interval for the population proportion, and you somehow have an estimation for the p-hat. That's not what we have. The next one is n equals 0.25 times the quantity z sub alpha over 2 divided by e squared. This is the sample size question you would use if you were looking at finding sample size when forming a confidence interval for a population proportion, but you don't have a pre-estimate for it. So that's not yet the formula that we need, because remember, we're looking at to be within so much away from the population mean. N is equal to z sub alpha over 2 times s divided by e quantity squared. This is the formula for finding the sample size if you're looking at doing this for a population mean. So this particular third one is the formula that we need for this problem. Okay, so what do we need to finish this out? We need to find z sub alpha over 2, s, and e. So z sub alpha over 2. Well, remember, z sub alpha over 2 is the z-score such that you meet the requirements of what percentage that you have. So it's to be 92% confident, and with confidence intervals, that percent is in the middle of the area. It's percent or that area, 0.92. Remember, the entire area under the curve is 1. So if I take 1, subtract the 0.92, I get 0.08 is the amount of area that's left for those two tails. That's your alpha. Now, if I want to find what area is in each individual tail, I'll take my alpha and divide by 2, because the standard normal curve is symmetric. So these areas will be the same as each other. So 0.08 divided by 2 is 0.04. That's how much is in each tail. Now what you do next is you either go to a table or you use a software package for statistics. This in particular I'm going to speak about using your TI-83 or TI-84 calculator. So if you have that, then you've got the percent you want the z-score. That's the inverse norm. Key. You get to that by going the second button and then the button that says VARS on the button, and then it has DISTR right above it. It's really close to your clear button. So if you see that, if you go second in that button, that gives you a lot of different distributions. That's where the normal CDF is, the inverse norm, the inverse T, and on through. So go and access that. Now the way that the software engineers programmed that key is they want the first part, when it says area, if you have a menu, or if it just looks like this on your screen, you have to remember area is the first entry. It's area that's fully left of that cutoff you're interested in. And I can think of it in two ways. One way is to say the entire area is 1, and 1 subtract 0.04 is 0.96. The other way is to say, well, if I am forever left of this cutoff, that would have to include the number 0.92 plus the 0.04, which is 0.96. Either way you think about that, that's what you want to have as that first entry. Then we want the mean of the distribution and the standard deviation of the distribution. Well, the mean of the z-scores is 0, and the standard deviation of the z-scores is 1. So when you go through and you calculate that, you will get 1.751. That's your z sub alpha over 2. Coming over to our formula, n is equal to my 1.751 times s. S is the sample standard deviation. And we look and it says that they did do a pre-sample of just 64 individuals and found a standard deviation of 97.49. So that's your standard deviation. So that goes where S is. And then if you happen to have the population standard deviation given to you instead of the sample standard deviation, it's fine to use that in the S slot as well. Now over E. E is that margin of error that they had predetermined and said that's as far as they want to be away from the population mean. So that our sample mean is within that. So when we look at the information that's in here, we see is within 12.58 of the sample mean. So 12.58 follows the word within, that's your E. Now when we go through and calculate that, we get n is equal to 184.133. But n is your sample size. It has to be a whole number and it has to meet the requirements that are set in the problem. So these you have to round up. So you're not rounding nearest, you're rounding up to the next whole number. So rounding this up, I have to take it up to 185. So your n is 185. Now, had this question said something like, how many more do you need to sample, and you already have information on 64 individuals, you would just take your 185 and subtract that 64. But if it just says, how many do you need in your sample, then you would report the 185.